हेलो बच्चों, वेलकम टू Alex International Online Tutorial. This is a free initiative towards educated India and free education for all. So today I am going to teach you electromagnetic waves. Okay. So in this chapter we will talk about all basic aspects and I will try to teach you in the best manner I can perform myself. So if you are not getting to understand, if you are not understanding the things I am teaching here, then you need to comment it. If it will be possible, then I will try to resolve that issue or problem. So, in this first segment of live session for class 12, probably this is the first lecture of class 12 in the live session. So, this is chapter 8. The number of chapter may vary. Welcome, Shyam Sundar. If you have not subscribed the channel, please do subscribe it. And this is electromagnetic waves. Electromagnetic waves. Now, the live will be mostly in lecture method, but if there will be any necessity of writing on the board, I will note it on the board also. So before starting the chapter, I just want to tell you a very short summary of this chapter, what we are going to understand in this lecture. After studying this lecture, you will find that you will be able to understand it that Maxwell found an inconsistency in Ampere's law and suggested the existence of an additional current. And can you name that additional current? Welcome, Abhinav. So, the name for that current is displacement current. So, we will learn here what is displacement current. Now, so to remove this inconsistency, the displacement current is due to time varying electric field, and it is given by ID is equal to epsilon naught upon dt, and x as a source of magnetic field in exactly the same way as conduction current. So we should start it from the beginning. Now I would like to introduce about Maxwell, J.C. Maxwell. J.C. Maxwell, James Clerk Maxwell, 1831 to 1879. Born in Edinburgh, Scotland, was among the greatest physicists of the 19th century, and he derived the thermal velocity distribution of molecules in a gas and was among the first to obtain reliable estimates of molecular parameters from measurable quantities like viscosity. So Maxwell's greatest achievement was the unification of the laws of electricity and magnetism. Discovered by Coulomb, Oersted, Ampere, and Faraday into a consistent set of equations now called Maxwell's equation. So from these he arrived at the most important conclusion that light is an electromagnetic wave. Interestingly, Maxwell did not agree with the idea strongly suggested by the Faraday's law of electrolysis that electricity was particulate in nature. Now, in this chapter, we will study that James Clerk Maxwell argued that not only an electric current but also a time varying electric field generate magnetic field. So while applying the Ampere's circuital law to magnetic field at point outside a capacitor connected to a time varying current, Maxwell noticed. So Maxwell noticed that an inconsistency in the Ampere circuital law, and he suggested the existence of an additional current, and that the displacement current. To remove this inconsistency, Maxwell formulated a set of equations involving electric and magnetic field and their sources, the charge and current densities, and these equations are known as Maxwell's equations. Together with the Lorentz formula, they mathematically express all the basic laws of electromagnetism. Now, what this led to? So, this led to the remarkable conclusion that light is an electromagnetic wave. So, Maxwell's work thus unified the domain of electricity, magnetism, and light. In 1885, in 1885, Hertz experimentally demonstrated The existence of electromagnetic waves, its technological use by Marconi and other led in due course to revolution in communication that we are witnessing today. Now, as you have heard right now, the name of displacement current, you must be a query that what is displacement current. So, my dear friends, Maxwell showed that for logical consistency, a changing electric field must also produce a magnetic field. And this effect is of great importance because it explains the existence of radio waves, gamma rays, and visible light, as well as all other forms of electromagnetic waves. Is it okay to you? So, to see how a changing electric field give rise to a magnetic field, let us consider the process of charging a capacitor and apply Ampere circuit law. Okay? Now, what we are seeing, it is given by, okay, you need to note it down. To find magnetic field at a point outside the capacitor, shows a parallel plate capacitor C, which is a part of circuit through which a time dependent current I. You can see here it changes with respect to time. So let us find the magnetic field at a point such as P in a region outside the parallel plate capacitor. For this, we consider a plane circular loop of radius r whose plane is perpendicular to the direction of current carrying wire. Now, the magnetic field is directed the magnetic field is directed along the circumference of the circular loop in the same in magnitude at all the point of the loop, so that B is the magnitude of the field. So what we have, B 2 pi r T. Got it? Now consider a different surface which has the same boundary. This is a pot like surface. Okay, so this is a pot like surface which nowhere touches the current but has its bottom between the capacitor plates. Its mouth is a circular loop mentioned above. Another such surface is shaped like a tiffin box. Okay, so on applying Ampere circular law to such surface with the same perimeter, we find that the left hand side has not changed, but the right hand side is zero. Since no current passes through the surface. Okay, so we have a contradiction. There is a magnetic field at the point P calculated. Another way, the magnetic field at P is zero. Okay, now if the charge Q on the capacitor plate changes with time, there is a current I is equal to dq upon dt. That will be so this implies that for consistency epsilon naught got it. So this is the missing term in Ampere circular law. If we generalize this law by adding the total current carried by conductors through the surface, another term that is epsilon naught times the rate of change of electric flux through the same surface, the total has the same value of current for all surfaces. Now, there is a new term for you that is called conduction current. Okay, so now you need to note it down. The current carried by conductors due to flow of charge. The current carried by conductors due to flow of charge or charges is called conduction current. Got it? Now, the current, what we have seen in the latest equation, where I is equal to epsilon naught this current is now renamed as displacement current, or this is also called Maxwell's displacement current. Got it? So the generalization made by Maxwell is the source of magnetic field is not just the conduction electric current due to flowing charges, but also the time rate of change of electric field. Now, but also the time rate of change of electric field. More precisely, the total current I is the sum of conduction current denoted by IC, the displacement current ID, that is equal to IC plus got it. The generalized the generalized and correct Ampere's circuitous law has the same form, that the total current passing through any surface of which the closed loop is the perimeter is the sum of the conduction current and displacement current. Okay, and is known as Ampere Maxwell law. What is it? This is what we have written. This is called Ampere's Maxwell's law. Okay. In all respect, the displacement current has the same physical effect as the conduction current. So in some cases, a steady electric field in a conducting wire, the displacement current may be zero, since the electric field does not change with time. In other cases, the charging capacitor, both conduction and displacement current may be present in different region of space. Different region of space. Got it? Now, there comes Faraday's law of induction, which states that Faraday's laws of induction. So it states that there is an induced EMF equal to the rate of change of magnetic flux. Okay. So we can rephrase Faraday's law of electromagnetic induction by saying that a magnetic field changing with time give rise to an electric field. Got it? Then the fact that an electric field changing with time give rise to a magnetic field is a symmetrical counterpart and is a consequence of the displacement current being a source of magnetic field. Thus, time-dependent electric and magnetic field give rise to each other. Faraday's law of electromagnetic induction and Ampere's Maxwell law give a quantitative expression of this statement. One very important consequence of this symmetry is the existence of electromagnetic waves, which we discuss qualitatively in the next section. Okay. So, this was an introductory class, and I am sure that you have understood it well. So in the next live, we will learn about sources of electromagnetic waves. Thank you for being with us. If you have not subscribed the channel still, you need to subscribe it so that you will be further notified for all the live and other videos, upcoming lectures. Thank you so much for being with us.